Hello and welcome to the next lecture video in Theory of Computation. In this lecture video, we will discuss on constructing a NFA for a given languages. There is no any specific rules for the construction of NFA. However, here are some points that can be useful while constructing a NFA for a given language. First, identify the basic string that belongs to the given language. That is, the string with minimal length and belongs to that language. We will discuss on this with example later on. Point number 2, represent the basic string identified in point number 1 using state diagram. Third, draw the state diagram of basic string to represent other strings that belongs to the given language. Note, do not define transitions for the string that does not belongs to the given language.
Let's clearly understand the above steps by taking some examples. Example 1. Construct a NFA that accepts set of all strings starting with 1 where alphabet sigma equals to 0, 1. Here the first step while constructing a NFA is to find a basic string, and the basic string for this language is 1. Since none of the string having length less than this string belongs to this language. Now we will represent this string by using a state diagram. So we start with the starting state Q0. Now reading this symbol in Q0 state leads to the next state Q1. Since this string belongs to this language, therefore we make Q1 as a accepting state. Now we will grow this basic state diagram to represent the other strings that belongs to this language. Here, whatever the symbols comes after this 1, that is either 0, 1 or as many, should be accepted. That means reading any symbols in Q1 state should also be accepted. Therefore, we make this transition on the state Q1. Here this point says that do not define the transitions for the string that does not belongs to the given language. In this case, the string 0, 1, 0 starts with 0, so we haven't defined the transition from Q0 state on reading the symbol this 0. Similarly, we haven't defined the transition for the string 0, 0, 1, 0, 0, since this string also starts with 0. As this state diagram represents all set of strings that starts with 1, therefore this is our required NFA. Now let's take another example, example 2. Construct a NFA that accepts set of all strings ending with 0, 1 where the alphabet sigma equals to 0, 1. Here the basic string that belongs to this language is 0, 1. Since none of the string having length less than this string belongs to this language. Now we will represent this basic string by using state diagram. So let's start with the starting state Q0. Reading the first 0 symbol in Q0 state leads to the state Q1. Then reading the next symbol, that is 1 in Q1 state, leads to the state Q2. Since this string belongs to this given language, therefore should be accepted, and hence we make this Q2 state as a accepting state. Now we will grow this basic state diagram to represent the other strings that belongs to this given language. For example, we have to represent the string 00, 0 1 0 1 0 1. Similarly 1 1 0 1. That means whatever the symbol comes before this 0 1, that is either 0 0 1 0 1, should be accepted, since 0 1 is in the last of that string. Therefore we make this transition on encountering the symbol 0 comma 1, since these symbols are consumed by this transition, and the checking of this 0 1 in the last is performed by this transition. Now let's check whether this string is accepted by this NFA or not. Initially our machine is in the state Q0. Reading this 0 leads to the state Q0 and Q1. Now reading this second 0 in Q0 and Q1 state leads Q0 and Q1, similarly dead. Now reading this 0 in Q0 and Q1 state leads Q0, Q1, and here dead. Now reading this final 1 in Q0 state leads to the state Q1, and reading 1 in Q1 state leads to the state Q2. That means reading the symbol 0001 in Q0 state may leads to the state either Q1 or Q2. As this set contains a state Q2 which is accepting state, therefore this string is accepted by this state diagram. Similarly, you can verify this string which is also accepted by our state diagram. Let's see one more example. Example 3. Construct a NFA that accepts set of all strings that contains 0 1 as a substring, where the alphabet sigma equals to 0 comma 1. Here the basic string that belongs to this given language is 0 1, since none of the other string having length less than this string belongs to this language. Now we will represent this basic string by using state diagram. So starting with Q0 state, reading the first 0 symbol in Q0 state leads to the state Q1, and reading the next symbol 1 in Q1 state leads to the state Q2. Since this string belongs to this given language, therefore should be accepted, so we make this Q2 state as a final state. Now whatever the symbol comes after this 0 1 should be accepted, therefore whatever the symbols comes in Q2 state, that is either 0 or 1, should be accepted, therefore we make this transition. Similarly, whatever the symbols comes before this 0 1 should be accepted, so we make this transition on encountering the symbol 0 comma 1 in Q0 state, so that the symbols that comes before this 0 1, that is 0 0 1, are consumed by these transitions, and the checking of this substring is performed by this whole transition. Let's see another example. Example 4. Construct a NFA that accepts set of all strings that contains 3 consecutive zeros, where the alphabet sigma equals to 0 comma 1. Here the basic string that belongs to this given language is 0 0 0, since none of the other strings having length less than this string belongs to this language. Now we will represent this basic string by using state diagram. Starting with Q0 state, reading the first 0 leads to the state Q1. Then reading the next 0 symbol leads to the state Q2. And reading the final 0 leads to the state Q3. Since this basic string belongs to this given language, therefore should be accepted, so we make this Q3 state as a accepting state. Now whatever the symbols comes after these 3 zeros should be accepted. Therefore whatever the symbol comes in this Q3 state should be accepted, so we make this transition. Also whatever the symbol comes before these 3 consecutive zeros should also be accepted. Therefore we make this transition on Q0 state, which will consume these symbols, and the checking of this 3 zeros is performed by this whole transition. So this is our required NFA. You can verify this string 00100 is accepted by this NFA, and the string 00100 is rejected by this NFA. Let's take one more example, example 5. Construct a NFA that accepts set of all strings that starts with 0 and end with 1, where the alphabet sigma equals to 0, 1. Here the basic string that belongs to this given language is 0, 1. Since this string starts with 0 and ends with 1, and none of the other strings having length less than this string belongs to this language, so we represent this basic string by using state diagram. Starting with Q0 state, reading first 0 symbol in Q0 state leads to the state Q1. Then reading this 1 symbol in Q1 state leads to the state Q2. Since this string belongs to this language and should be accepted, therefore we make this Q2 state as a accepting state. Now whatever the symbols comes between this 0 and 1 should be accepted. Therefore we make this transition on encountering the symbol 0, 1 in Q1 state, so that these symbols are consumed by these transitions, and the checking of 1 in the last is performed by this transition, and the checking of this 0 in first position is performed by this transition. So this is our required NFA. Remember, while constructing a NFA for a given language, you should only think about the strings that belongs to the given language, and do not worry about the strings that does not belongs to the given language. Here the set of strings that belongs to this given language have the general structure 0, then any symbols comes after this 0, and finally 1. And none of the string other than this structure belongs to this language. Therefore we only consider this type of structure while constructing a NFA. Let's see one more example, example 6. Construct a NFA that accepts set of all strings that starts and ends with same symbol, where the alphabet sigma equals to 0, 1. Here the basic string that belongs to this language are 1, 1 and 0, 0. Since these are the two strings that starts and ends with same symbol, and none of the strings having length less than these strings belongs to this language. Now we will represent these two strings by using state diagram. So starting with Q0 state, now we first represent this string. Reading 1 in Q0 state leads to the state Q1. Then reading 1 in Q1 state leads to the state Q2. Since this string belongs to this given language, therefore we make this Q2 state as a accepting state. Now we will represent this basic string. Now reading 0 in Q0 state leads to the state Q3. Then reading next 0 in Q3 state leads to the state Q4. This string also belongs to this given language, therefore we make Q4 as a accepting state. Now the general structure of the strings that belongs to this given language are 1, then any number of symbols, and finally 1, and 0, then any number of symbols that may be either 0 or 1, and finally 0. And none of the strings having structure other than these belongs to this language, so we only consider these two structure while making the NFA. Now representing this structure, here this one is represented by this transition and this one is represented by this transition. Now whatever the symbols comes between these twos should be accepted, hence this symbol is consumed in Q1 state, that is 0, 1. Similarly, whatever the symbols comes between these two zeros should be accepted, therefore whatever the symbols comes in Q3 state is consumed by this Q3 state. So this is our required NFA. Example 7. Construct a NFA that accepts set of all strings that contains 0, 1 or 1, 0 as a substring, where the alphabet sigma equals to 0, 1. Here the basic string that belongs to this given language are 0, 1 and 1, 0. We first represent these basic strings by using state diagram. So starting with Q0 state, now reading this 0 in Q0 state leads to the state Q1. Then reading 1 in Q1 state, this one in Q1 state leads to the state Q2. Since this string belongs to this given language, therefore we double circle this state. Now representing this string, reading 1 in Q1 state leads to the state Q3. Then reading 0 in Q3 state, this 0 leads to the state Q4. Since this basic string also belongs to this given language, therefore we make Q4 as a accepting state. Now whatever the symbols comes after this 0, 1 should be accepted, therefore we make this transition on 0 and 1. And also whatever the symbols comes before this 0, 1 should also be accepted, so we make this transition on encountering the symbol 0, 1 in Q0 state, which will consume these symbols, and the checking of 0, 1 is performed by this transition. Similarly, in case of this basic string, whatever the symbols comes after this 1, 0 should be accepted, therefore we make this transition on Q4 state. Similarly, whatever the symbols comes before this 1, 0 should also be accepted, therefore we make a transition from Q0 to Q0 on encountering the symbol 0, 1, which is already present here. Here none of the strings other than these structures can belongs to this language, therefore this is our required NFA. Let's see one more example. Example 8. Construct a NFA that accepts set of all strings whose third last symbol is 1, where the alphabet sigma equals to 0, 1. Here the basic strings that belongs to this language are 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. We can represent these 4 basic string as 1 blank and next blank, where these blank symbols may be either 0 or 1. Now we will represent this basic string by using state diagram. So let's start with the starting state Q0. Now reading the first symbol, that is 1 in Q0 state, leads to the state Q1. Now reading the blank symbol, which may be either 0 or 1, leads to the state Q2. Then reading the next blank symbol, which is also either 0 or 1, leads to the next state Q3. Since this basic string belongs to this language and should be accepted, therefore we make this Q3 state as a accepting state. Now whatever the symbols or strings comes before this basic string should be accepted, therefore we make this transition on the state Q0, which will consume all the strings or symbols that occurs in front of this substring. And then this substring is represented by this whole transition. As none of the strings other than this structure belongs to this language, therefore this is our required NFA. Let's take another example. Example 9. Construct a NFA that accepts set of strings 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1. Here we start with starting state Q0. Now reading this 0, we switch to the next state Q1. Since this 0 belongs to this language, therefore we accept that 0, so we make this Q1 as a accepting state. So this is accepted by our this state diagram. Now we will represent this string. So we start with the starting state Q0. Now reading the first 0 leads to the state Q1, and reading the next 1 symbol, we switches to the next state Q2 and make this Q2 as a accepting state. So this is also accepted by our NFA. Now we will represent this string. For this we start with the starting state Q0. Now reading the first symbol, that is this one, leads to the state Q3. Then reading the next symbol, that is 0, leads to the next state Q4, and we make this Q4 as a accepting state to accept this string. Now to represent this string, we start with the starting state. Now reading the first symbol 1 from Q0 state leads to Q3 state, and then reading the next symbol 0 in Q3 state leads to Q4 state, and then reading the last symbol, that is this one, in Q4 state leads to the Q5 and make this Q5 state as a accepting state. And finally for this string we start with the starting state Q0. Reading the first 1 symbol leads to Q3 state, and reading the next 1 symbol in Q3 state leads to the next new state Q6, and then reading the last 1 symbol in Q6 state leads to the state Q7, and we make this Q7 state as a accepting state. So this is our required NFA. Here we can reduce these 3 states into one state, let's say R, and make a transition on this R state, then these individual states, so that our final DFA contains minimum set of states, which we will cover on the topic minimization of finite automata later on. That's all in this lecture video. If you have any queries related to NFA, then please leave the comment and I will try to solve that question. Hope to see you in next lecture video, and thank you for watching this video.